Hello everyone, my name is Fatima and today I'm going to talk about our recent work called Hybrid S2S, Video Object Segmentation with Recurrent Networks and Correspondence Matching. This work was done together with my colleagues at TU Kaiserslautern and DFKI. First, a short introduction about one-shot video object segmentation. In this task, we are interested in tracking and segmenting a target object where the first mask of the object appearance is provided. There are different challenges for video object segmentation that needs to be handled properly to achieve a good performance. One could name amongst these challenges like fast motion, motion blur, tracking objects with various sizes, handling occlusion, as well as error propagation and appearance change. In the literature, there have been different methods proposed for solving this task. One category of the methods rely on using recurrent neural network as a natural way for memorizing the object of interest throughout the whole sequence. RNN learns the spatiotemporal model of the target object and this way manages to track the object of interest during the whole video. Another category of the methods is based on correspondence matching. These methods detect the target object by a template matching with a reference frame. Further extensions of this category are possible by using external memory in order to provide more context to the model. In this work, we refer to the RNN-based solution as our baseline. Specifically, we chose S2S method as our starting point. This method consists of an initializer, an encoder and decoder, and an RNN module in the bottleneck. The initializer, which is a VGG16, as input receives the first RGB and the first segmentation mask and generates the hidden states of the RNN. The RNN is responsible for remembering the target objects while receiving this initialization. We observed that this method suffers from multiple limitations. One limitation is the poor performance in longer sequences that we believe is due to error propagation and drift in the RNN. Another problem is the limited memory of the RNN and the vanishing gradient. This causes less access to the information in earlier frames and causes difficulties in handling occlusion as a result. Here we can see a couple of examples that in the beginning of the sequence, this model manages to segment the objects properly, but as we proceed in time, the segmentation quality degrades. Here is another example that after some time we see that the network is confused and there is some parts of the image that is segmented which is not the part of the target object. The same pattern can be seen in this example, that after some time, as the time proceeds, the method starts to generate erroneous segmentation masks. Now I want to briefly discuss about the methods that utilize correspondence matching. In these methods, we propagate the object mask by detecting the similarities between a reference and the target frame. The reference frame is the frame at time step 0, where the ground truth object mask is provided. But these methods have also certain limitations, such as poor performance when the object shape changes drastically, since the model cannot detect the similarity between the target frame and the reference frame. And also, the model has poor performance when there are similar object instances in the scene, since the model is not able to differentiate between the similar instances. For this work, our intuition is that RNNs and matching are complementary. RNNs provide the model with motion cues and location prior. This is useful when there is a drastic appearance change, since we still know the approximate location of the target object. This is also useful when there are similar objects in the scene, since by using this location prior, we can eliminate the ambiguity of the target object. But also, correspondence matching is complementary for RNN, since it provides a strong measurement for segmentation. This can be especially useful in the presence of occlusion, and also it can help the model to reduce the error propagation by fusing more information to the model. Here I will talk about our proposed method, which is a hybrid model by fusing the RNN and matching best information. In this architecture, we augment the spatiotemporal features from RNN with correspondence matching. Specifically, we use the frame as at time step 0 as the reference frame, and we also provide a dual propagation by using a second reference frame at time step t-1. This way, the model has always access to the information in the first frame, which is reliable as it is the provided label, and also by using the correspondence matching at time step t-1, we have this dual propagation strategy that augments the RNN features with the correspondence matching information. We fuse this information from different branches via a fusion layer, which combines these branches and provides the input to the decoder that finally generates the segmentation mask. When looking at the results, we saw that this hybrid mechanism can lead to significant improvement compared to both RNN-based and matching-based methods for video object segmentation. This proves our hypothesis that these methods are actually complementary, and for achieving the best performance, we can merge these two without introducing much overhead to the network. It's worth mentioning that the S2S method is our baseline, and RGMP is also another method for video object segmentation that purely relies on matching. In this slide, we can see an ablation study just to analyze the impact of different components of our method. We can see that using the first frame as reference, namely HS2S0, and the dual propagation strategy, namely HS2S T-1, both improve the results. And the improvements of these two techniques are additive, resulting in best performance when we use them together. In this table, we can see the results from the original paper S2S, as well as S2S star, which is our reimplementation of this model by replacing the VGG encoder to a modified version of ResNet 50. Here we can have a look at the results of our model. We observe the improved performance, especially for the difficult scenarios, such as the cases that we have very long sequences and also in the presence of occlusion. We can see that the model is more robust, especially in the later sequences where the RNN-only method struggles to achieve a good performance. Also, due to using the location prior from the RNN, the model manages to discriminate between very similar instances of the same object. Finally, we provided an analysis of the performance of our model quantitatively in the presence of occlusion and longer sequences. Here on the left, you can see a distribution of the sequence lengths in U2VOS dataset. So we can see that the maximum length of a sequence is 35 frames. Therefore, we considered the frames before the time step 10 as easy and the frames after time step 20 as hard. Then we evaluated both S2S method and our HS2S method on these easy and difficult scenarios. We observed that our method outperforms the S2S method in both easy and hard scenarios. But specifically in the case of longer sequences, which are harder for the RNN-based method, our HS2S method manages to close the gap between the easy sequences and the hard sequences. We did a similar analysis for evaluating the performance of our method in the presence of occlusion. First of all, we provided the distribution of occlusion lengths in different sequences of U2VOS. When considering different thresholds for considering a frame or object as occluded. Here we are considering 0 pixels, 50 and 100 pixels. So it means that if an object has less than 50 or 100 frame, in that scenario we consider that as an occluded scene. Again, we observe that our method improves the performance considerably compared to the S2S, and we believe that this is mainly due to using the information in the first frame and using the correspondence matching and the information in the first frame that can be really useful for handling the occlusion. Finally, I would like to thank you for your attention. For accessing the code or seeing more results, please visit our project page, and please don't hesitate to contact me if there is any question or comment or feedback. Thank you very much.